Okay, so today we're working on 5.5, which is solving rational equations and inequalities. We're actually going to skip this inequalities part, and we're only going to focus on the equations in this lesson. That's the only thing that's going to be on your quiz and on your test is the equations. So first, what we're going to talk about, actually, before I start talking, just keep in mind that throughout this video, you can pause it whenever you want. I'm going to try to give you little reminders every once in a while when you might want to pause. But do remember you can always do that if I'm talking too fast or if you want to write something down. Make sure you remember that you do have that ability to pause. So what I want you to do first is look at this warm up, and I want you to try it on your own, just like you would if we were in class. Take a few minutes, try it out. Make sure you remember when you're multiplying two things with the same base, you're adding your exponents, and when you are dividing, you're subtracting your exponents. So take a few minutes. I'm going to put the answers up right now, so remember, pause it if you want to do them on your own first. So these are pretty self-explanatory. That last one is a little bit, I don't think tricky, but you just got to remember our smaller exponent was on the top. Again, you can think about it like this, where you have 2y's on the top and 5y's on the bottom. So if you divide through, you will have 3y's left over, but they will be on the bottom. So that's why you need that 1 as a placeholder. Okay. Our next warm-up is everyone's favorite thing. We have some factoring. So again, before I pop the answers up here, make sure you're trying them on your own. This first one is a pretty straightforward one. We're just looking for two numbers that multiply to be this last thing, add to be this middle thing. Make sure you're careful with your signs. Again, hopefully you've tried these on your own already because I'm popping up the answers right now. So again, we're just factoring, we're not solving. There's nothing to solve here. This next one, number 6, is for some reason a problem that a lot of people have a hard time with. I think you guys overthink this one, but you're looking for everyone's favorite, a GCF. So all we can do there is take out a GCF. And number 7, it's actually a 2-step problem. Our answer looks like this. We had a GCF first, and our GCF was x cubed. So then that left us with x squared minus 9 inside the parentheses. And we all know that is Miss Stinky's favorite type of factoring problem, a difference of squares. So hopefully when you did this on your own, you also recognize that. But that is where this answer came from. Okay, now let's actually move on to our lesson. Now we've talked about rational expressions before in 5.2 and 5.3. So remember, a rational expression is just when you have an x in the denominator of a fraction. Or it could also be in the top, but we're focusing on x's in the denominator or the bottom of a fraction. Okay, now remember, this is something we talked about before. When you're checking your answers to see if they work, make sure you see if anything makes the denominator equal to 0. Remember, whenever you have something, let's say 3 over, where'd that go? 3 over x minus 2. Remember, if you have x minus 2 in the bottom, that means x is not allowed to be 2. X can be all real numbers except, in this case, 2. But whatever makes that denominator equal to 0. So just keep that in mind. It's going to come up a few times later in the lesson. Okay. So again, a rational number is a fraction. So a rational equation is going to be not just an expression. We're now going to have an equal sign on the other side. So instead of, say, like we had on the last side, 3 over x minus 2, we might have 3 over x minus 2 equals 7 over x minus 3 or something like that. So now instead of just having a expression, we have an equal sign and we're going to have to solve it. Okay, so remember, rational expressions are basically just fractions with variables, okay? All right, so we're going to move on from here. Okay, now when we're actually solving rational expressions, And this problem right here is actually going to be our example 1. So if you want to write that down, I mean, it's going to come up again, but that's going to be our example 1. So the thing that makes this problem a little bit ugly is that it has an x on the bottom. And whenever something is on the bottom and you don't like it, think about what you do to get rid of that. Like if you have x over 2 equals 5, how would you get rid of this 2 on the bottom? Hopefully you thought of multiplying it. So we multiply the 2 on both sides, and now we have this much prettier equation that just says x equals 10. So if we don't like something in our problem and it's on the bottom, we can get rid of it. Sorry, I'm just cleaning this up here. If we don't like something on the bottom, we can get rid of it by multiplying by it. Now, sometimes there might be more than one thing on the bottom, but what you're going to have to do, if you remember like we had in 5.2, you're going to have to find the least common denominator of the expressions, and you're going to multiply each term, every single term of the equation, by the least common denominator. Then what happens is the denominators go away and it becomes an easier problem. So instead of talking about it, let's just do a problem like this and see if it works. Okay, so our first problem is this. Again, if you need to pause and write it down, pause and write it down. So I'm just going to get right into it here. And again, you might want to try it, or maybe you watch this example and then try the next one on your own. Okay, so again, what you want to do is you want to find first the least common denominator. Now, if you think about this as x over 1 and 3 over, 3 over 1, you really only have one thing on the bottom, and that is x, okay? Or again, if you want to think about these ones, you have 1x. So once you find that, what you want to do is you want to take that x and you want to multiply it by every single term. So we take our first term, which was already x, and we multiply it by x. We take that second term, which was 18 over x, and we multiply it by x. We take that thing on the right side of the equal sign, which was just a 3, we multiply it by x. Okay, so we're multiplying every single term by x. Okay, now we're going to go through and see what each term is. So we have x squared, x times x is x squared. Now this second term right here, we had an x on the bottom and we multiplied it by an x. That means they're going to cancel out. So that is just 18. So then we get x squared minus 18 equals 3x. The whole point of this step right here is to get rid of all denominators. So you just have an expression that, or sorry, an equation that doesn't have any fractions in it. So if you do this step and you still have fractions left, then something is weird and you might have done something wrong. Okay, so now we're going to, this is a quadratic. So remember, with a quadratic, you want to get everything onto the same side. In other words, you want to set it equal to 0. So on this side, we're going to get x squared minus 3x minus 18 equals 0. Okay? So we're not finished yet. Remember, when it says solve, you want your answer to say x equals blank. If x is not alone, you're not finished. Okay? So what we're going to do now is we're going to continue solving this. Now this has just become a factoring problem. So I know all of us love factoring. Again, this is factoring a quadratic. You might want to brush up on those skills either in your notes or maybe finding another video. So we're going to solve this. Remember, we're looking for two numbers that multiply to be this last thing, add to be this middle thing. Those numbers, again, try to think of what they are before I tell you. Again, you can pause it if you need more time. But those numbers are x minus 6 and x plus 3. Once you get down and it can't be factored anymore, you're going to take each one of those factors and set them equal to 0. Okay, and then you're going to solve. Okay, so you're going to get x equals 6 and x equals -3. Now, we're basically done. I mean, we are finished with the actual problem itself. So those would be our answers. Those are going to be our answers, but notice this also says check. Okay, now let's check this and see what happens. So we get x, let me write this a little smaller so I can fit it all. Oops. Okay, so we have x minus 18 over x equals 3. Okay, so we're first going to try this plugging in the 6. Okay, so we're going to say 6 minus 18 over 6 equals 3. 18 divided by 6 is 3, so 6 minus 3 equals 3. So we're asking ourselves, does 3 equal 3? I hope that you know that that does. Okay, so that's our first one. So we plugged in 6 and it worked. Okay. Now, let's try the same thing with -3. So we're going to have -3 minus 18 over -3 equals 3. A lot of 3's in that one. So we have -3 minus, if you just look at 18 over 3, you get -6 equals 3. We have that double minus there. It turns into a plus. So -3 plus 6 equals 3. 3 equals 3. And that works. So that also works. Both of those are correct answers. Now, you might say, Miss Sankey, that took forever. I don't feel like doing all that work. I'm running out of time. I have a quiz and it's timed. What do I do? At least if you're not going to fully do a whole check like this, at least plug your numbers back into any x's that are on the bottom. Make sure that the bottom does not equal 0, okay? If you don't want to go through and check every single one totally thoroughly, then at least check it in the bottom really quick. Okay. So again, if you need to pause this and write down any of this work or catch up, feel free to do so. Okay. Oh, I already had the answers in there. What do you know? All right. So next one. Next one says just to solve. So it says 10 over 3 equals 4 over x plus 2. So again, you want to look at what your LCD is, your least common denominator. So on the bottom, we have a 3 and we have an x. If you just have two things like that that are totally different, your least common denominator is going to be those two things multiplied by each other. Because to get rid of the 3 and the x, you definitely need to multiply by 3 and you definitely need to multiply by x. If you multiply only by 3, the x will still be left on the bottom. If you multiply only by x, the 3 will be still left on the bottom. So you want to make sure you multiply everything by 3x. So we're doing 10 over 3. Again, we're multiplying by that LCD. So we're multiplying it by 3x. And that's going to equal 4 over x. Oops. Times 3x plus 2 times 3x. So literally every single term, if there's 20 terms, sorry, I gotta multiply every single one of them by this least common denominator. Okay, so when we have 10 over 3 times 3x, the 3 is on the top and the bottom, so it cancels out. We are left with 10x. Okay, on the other side of the equal sign, here, our x cancels out with our x, and we're just left with 4 times 3, which is 12. Then we have 2 times 3x. That gives us 6x. Now, this is amazing. We don't even have a quadratic. This is a straight up linear equation. All you have to do when it's linear is just get all your x's to one side, all your numbers on the other. I'm going to come up here. So we have 10x equals 12. Oops. Let's make that right. Okay. 12 plus 6x. We're going to subtract the 6x from both sides. We get 4x equals 12 over 4 over 4, x equals 3. So x equals 3, and this one does not say check. You can if you want. You will be working with a little bit of fractions, but you can do that. Just again, make sure if you plug 3 into this bottom x, it's not 4 over 0, which it's not. It's 4 over 3, so that's totally fine as far as that's concerned. Luckily for you, I already did check it, and it is correct. So we won't check that one. But again, if you ever want to know for 100% sure that something's right, just plug everything back in. Okay. Next one. All right, so example 3 says x equals 6 over x minus 1. Again, if you want to try it by yourself, take a minute now. Maybe you already have. So what we're going to do here is first find our LCD. So again, our LCD is going to be whatever's on the bottom. Again, only this one has a denominator. You can think of the other ones as 1. So our LCD is just that denominator by itself. Nothing else necessary. So we're going to take that denominator and multiply it by everything. So we have x times x equals 6 over x times x minus 1 times x. Okay? So as we go through here, we're going to say x times x, nothing cancels out there. X times x is x squared. Then these cancel out, so we have 6. And then this is just minus 1x. Now again, this is a quadratic, so with a quadratic we want to make sure everything is on the same side, okay? And we would like our x squared to stay positive. So let's move these two things on this side over here. We're going to do that by subtracting the 6 and adding x. So subtracting the 6, adding x. So here we're going to be left with x squared plus x minus 6. And here everything cancels, so we're left with 0. Okay, so again, let's come back up here. So we have x squared plus x minus 6 equals 0. So again, we're looking for two things that multiply to be the c term, add to be this b term. Again, think of those if you want, and those things are going to be x plus 3, x minus 2. Okay? So if we set these equal to 0, we will be able to solve our problem. Okay? So on one hand, we have x equals negative 3. On the other, you have x equals 2. So x equals negative 3 and x equals 2. Okay? Again, if you want to plug these back in and make sure they work, spoiler alert, they do work. So we're going to get a little bit more serious about checking them in a minute on our next few examples. But these do work, and again, you can plug them in. Again, this is where you want to make sure negative 3 and 2, neither of them make that bottom 0. So we're good to go there. All right, so now we're going to see some stuff that's maybe a little bit more interesting start to happen as we hit example 4. Okay, so again, those are our correct answers. Okay, so now we're going to talk about what happens when we plug something in. We did everything right, all our math was great, but when we plug it back in, it doesn't work in our original equation. Okay, so in these types of problems, it's very possible to get these. That's why it's really important that you check your answers, okay? A few things might happen here. Sometimes you might get 2 solutions and they both work. Yay! That'd be great. Sometimes you might get 2 solutions, only one works. You could get 2 solutions and none work. You could get 1 solution and it works. You could get 1 solution and it doesn't work. Now, in other classes, you could get, 3, 4, 5 solutions, but we're focusing mostly on quadratics here, so we'll be mostly getting, at the most, 2 solutions. Now, if you get 2 answers and neither of them work, or you get 1 answer and it doesn't work, you basically have no solution. So that could definitely happen, or sometimes you're just going to have 1 solution out of 2 that works. For me, if you're like writing work or showing me something and it's a free response, I would like you to tell me what the answer was that didn't work, which I'll show you in a minute what I mean by that. Okay, so let's see what happens. Okay, so here's a problem. So we have 5x over x minus 2 equals 3x over x minus 4. Now something interesting happens here. We have 2 things here that have the same denominator, okay? So that is our LCD, and I'll show you what happens because there's kind of a shortcut. Not 5, that's not correct. Sorry, I got ahead of myself. Okay, so our LCD is x minus 2. Now if we multiply x minus 2 up here and x minus 2 up here, both of these are going to cross out, which is just leaving us with whatever was on the top. So that's kind of a little secret hint that you should know. If your denominators are both the same, you only have 1 denominator and no other terms. Like if we had like a +1 over here or something, this would not work. But since we only have 2 terms and they have the same denominator, we can kind of just get rid of that denominator for now. Okay, so now we're just left with this nice simple linear equation. When we solve it, again, we're getting all our x's on one side, all of our numbers on the other side. So we get 2x equals 4. We divide both sides by 2, and we get x equals 2. Now, that looks so nice. We did such a good job, right? Now, I know I crossed some stuff out here, but let's go back to our original problem. Okay, what do we notice is going on in that original problem? In that original problem, we have a denominator of x minus 2, okay? What would happen if we plug 2 in right here? On this side, we would get 10 over 0. Uh-oh, that's not good. So, since we got 10 over 0, that's bad. When we have 0 in the denominator, remember, that does not work, okay? So, even though we did all our math right and everything was beautiful, this is what's called an extraneous solution, okay? So, there's actually no solution to this problem. Again, for me, I would like all of this. If it's some, again, we'll try to figure out how we're having these quizzes and tests online. But if there's a place for you to write this, that's really ideally what I would like. But I believe in your homeworks that I looked at before, if there's a problem like this, it's just a no solution as your answer. So nothing works in this problem, so that is correct that there's no solution. I do just like you to acknowledge what was the answer that we got that didn't work. But again, the official technical answer here is no solution. Okay? All right, I think that's going to pop up and we can't read it. Okay. So, let me erase this so you can see that. Okay. So yeah, what this says is our answer is no solution, but x minus 2 is what you get, but it's extraneous. So I would, again, like you to acknowledge that we got to, but it was extraneous. But our answer is no solution. Okay. Next. All right, one second. All right, so now we have another one again. Pause it, write it down, maybe try it, but we're going to move on here. Okay, so here we have 2 denominators. We have x minus 8 and we have 2. Then we have another x minus 8, but again, we don't have to use a repeated denominator twice. So to get rid of all these denominators, what we need here is x minus 8, not 2, x minus 8 and 2. So we're going to multiply everything here by 2 times x minus 8. Now, this has 3 terms. It's a little longer. There's more stuff going on than our last one. So be careful. Give yourself some room and some space to show work here. So we got 2x minus 5 over x minus 8. It might be good for you to put everything in parentheses just to kind of make your life easier so you can kind of see which terms are where and what's connected to what. So we have 2x minus 5. Again, we're multiplying everything by 2 times x minus 8. Then we have x over 2 times 2 times x minus 8. Then we have, and again, that's over 2, like in the original problem. Then we have 11 over x minus 8 times 2 times x minus 8. Okay, so now we're going to go through, we're going to see what cancels off the top and bottom. So in this first term, we have x minus 8 on the bottom. That cancels out with the x minus 8 on top. You are left with 2 times 2x minus 5. Our next term, we have a 2 on the bottom and a 2 on top. So you are left with x times x minus 8. Okay? Next one, you have an x minus 8 on the bottom, x minus 8 on top. You are left with 11 times 2, which is 22. Okay, now we got to clean this up a little here. So we're going to distribute this 2, which is going to give us 4x minus 10. We're going to distribute this x. That's going to give us x squared minus 8x. And our 22 is the same. So again, keep cleaning up. Get some like terms together over here. So we got x squared. Again, I like to kind of circle things as I use them so I know. Okay, then we have a 4x and a negative 8x. That's going to give us negative 4x. And then we have a negative 10. All of that equals 22. Now again, since it's quadratic, we want to get everything on the same side. So we're going to take this 22 and we're going to move it over. So that gives us x squared minus 4x minus 32 equals 0. Okay, now this is our favorite kind of problem, a factoring problem. So now we have, oh, that one went yellow, sorry. Okay. So now we have x squared minus 4x minus 32 equals 0. We're going to find two numbers that multiply to be negative 32, add to be negative 4. And those are x minus 8, x plus 4. Again, I can feel myself going kind of fast here, but always pause and kind of take stock and see if you understand one step before you move on to the next step. So we got x minus 8, x plus 4. Then we're going to take each of these and we're going to set them equal to 0. Okay, so we're going to get x minus 8. And we solve that, we get x equals 8. And we're going to subtract 4 from both sides here and get x equals negative 4. Now, we just did all this beautiful work. We got these two beautiful answers. Now, plug these back in to the bottom of the equation. Again, you can plug it into the whole thing, but our real concern right now is the bottom of the equation. So, if we plug 8 in here, 8 minus 8, I believe that is 0. And that does not work. So this 8 is extraneous, and this 4 works. So again, your official answer to this problem is x equals negative 4. Okay, so that is your answer. Again, if I was able to like look at all your work, what I would really want to see is this whole thing down here where we got the two answers, but we found that one of them is extraneous. But again, I don't know exactly how we're going to be doing our quizzes and tests here online. So if it only asks you for like what is the actual answer, it's going to be -4. Again, we can clarify that stuff when we come to a quiz, but -4 is your official answer. 8 was extraneous. Okay. My answer is going to pop. Oh no, I mixed those up. That's not good. Don't read that down there. That's bad. Okay. So x equals -4, and the 8 was extraneous. Okay. So x equals -4, and the 8 was extraneous. Okay. Now, our next thing says 16 over x squared minus 16, 16 over x squared minus 16 over, okay, I can't talk right now, 16 over x squared minus 16 equals 2 over x minus 4. Now, you might recognize this denominator on the left side as, again, one of my favorite factoring problems, a difference of squares. So you might recognize that as x minus 4, x plus 4. So if we're looking for an LCD here, both of these denominators have an x minus 4 in common, so we definitely know x minus 4 is part of our LCD. But if we want to get rid of the whole denominator, we also have to multiply by this x plus 4. Okay, so our least common denominator is x minus 4, x plus 4. So that means we're going to multiply both of these things by x minus 4, x plus 4. So the denominator of that one is x minus 4, x plus 4. We're going to multiply it by x minus 4, x plus 4. This other one over here had x minus 4 on the bottom. We're going to multiply it by x minus 4, x plus 4. Okay. Now, over here, our whole denominator is going to cancel. Again, that's the goal. If you do not get the whole denominator cancel, something is wrong. Okay. So 16 is all you're left with over here. Now here, our x minus 4 cancels, and you're left with 2 times x plus 4. Okay. We have to make sure we distribute that too. So 16 equals 2x plus 8. We subtract 8 from both sides. 8 equals 2x. We're dividing by 2 on both sides. We get x equals 4. Yay! Now, what happens though? If we plug 4 into here or into here, I don't think that's going to be good. We're going to get 0 on the bottom. So we only got one answer, and that one answer did not work. It is extraneous. So our answer here is no solution. Okay? So again, make sure you're checking those answers in the bottom of this equation. Okay. All right, this is our last regular example. Then we have 2 quick word problems, and then we will be finished. I promise the word problems aren't that bad. I know whenever you hear that word, we don't like it, but they're fine. Okay, so here we have 2 different denominators. Again, this one's the same as this one over here. So if you have 2 denominators that are the same, just using it once in your LCD is enough. Okay, so our LCD is going to be 6 times x minus 1. Okay, so our first thing here, we have 1 over x minus 1 times 6 times x minus 1. X over x minus 1 times 6 x minus 1 plus x over 6 times 6 x minus 1. Okay, now over here, our x minus 1 is going to cancel, which means we're just going to be left with 6. Over here, our x minus 1 again is going to be canceled out, but we have 6x over here. And then over here, our 6's are going to cancel out, which leaves us with x times x minus 1. Okay, now here, you're going to make sure we distribute this to clean it up here. So we got x squared minus x. Since it's quadratic, we want everything on the same side. We want our x to stay positive. Before we move stuff, let's get our like terms taken care of. So we have x squared plus 5x over here. We have 6x and negative x. Now we just have to move the 6 over so it can join the party. So that leaves us with x squared plus 5x minus 6. Okay, I'm going to bring it up top to the right side here. So we have 0 equals x squared plus 5x minus 6. Again, we're going to factor this. Maybe factor it in your brain really quick before I spoil it. Okay, so we're looking for two numbers that multiply to be negative 6, adds to be positive 5. Make sure you check your math. A lot of people always put 2 and 3 here, or they put the wrong signs, 5 and 6. We're trying to multiply to be negative 6. We're trying to add to be positive 5. Okay, so check your math real quick. We got to do x plus 6, x minus 1. Now, when we take those factors and set them equal to 0, we're going to get x equals negative 6 and x equals 1. Now, again, we did all this beautiful math. Let's see what happens. If we plug in negative 6 in here into our x in our original problem, we get negative 6 minus 1. That seems great. It's not 0. So we like the negative 6. But if we plug in the negative 1, we're going to get 1 minus 1, which is 0. Okay, so wherever you plug it in, it's not going to work. So the negative 1 is extraneous. Okay? So your answer is x equals negative 6, and your negative 1 is extraneous. Okay. Now, let's see how we can solve a word problem with rational equations. Okay. So, I don't know if any of you guys have heard these types of problems before, but we have these, what they're called work problems, is how long does it take people to do stuff. So this says Natalie can finish a 500-piece puzzle in about 8 hours. When Natalie and Renzo work together, they can finish a 500-piece puzzle in about 4.5 hours. About how long will it take Renzo to finish a 500-piece puzzle if he works by himself? Now, I think I put the answer on the slide, so I can't go to the next one. But basically, what we have, let me go really fast. Okay, because I want this. So what we have to think about is how much or how many puzzles is Natalie going to do in an hour. So that's what we call a rate, okay? So if Natalie takes 8 hours to do one puzzle, think about if you only gave her 1 hour, how many puzzles could she do? Okay, I know that doesn't make a lot of sense, but think about if it takes her 8 hours to do one whole puzzle, and you only give her 1 hour, she will have done 1/8 of that puzzle. Okay, so her rate is 1/8 because she does 1/8 of a puzzle per hour. Now Renzo, he's our mystery man here. We do not know how long he takes. So again, let me, I don't want you to see the answer here. So go back here. So Natalie, 8 hours together. Sorry, I didn't give you enough time on this slide, so maybe write that down. Together, they go about 4.5 hours. And so what we're trying to find is Renzo's rate. He's the mystery man. Okay, so again, write maybe those 3 things down. Natalie's 8 hours. Together, they're 4.5. And Renzo, we don't know. You just maybe saw the answer there, but it's not about answers. It's about learning. So Natalie works Her rate is 1/8 of a puzzle per hour. Renzo, we don't know how many puzzles he does an hour. So again, an unknown value is an x. Now together, we know they can do one puzzle every 4.5 hours, or 1/4.5 of a puzzle in an hour. Okay, now this just becomes one of the problems that we've just done. We have to look at all of our things down here, and we have to make a common denominator. Okay, so we have to make a common denominator so that we can get rid of it. So in other words, we have to look at, we got an 8, we got an x, and we got a 4.5. So it's just all three of our denominators, and we're going to multiply by all of those. So 8 times x times 4.5. We're going to do that on each one. So 8 times x times 4.5. So this is the same thing that we were doing before. It's just the setup was the tricky part here. Okay. So now we look and see what cancels. So our 8's cancel here. So we're just going to have 1 times x times 4.5, which gives us 4.5x. Here our x's are going to cancel, which gives us 8 times 4.5, which if you do that, it's 36. And then our last one, the 4.5s are going to cancel. So we're going to end up with 8x. So again, this is a nice linear equation. So you're just going to subtract the 4.5 from both sides, the 4.5x. And you're going to end up, 4.5x. You're going to end up with 36 equals, you might need a calculator this part if you need to, but that's 3.5x. You're going to divide on both sides by that 3.5. Again, on these, unless you have x equals, your answer is not finished. So make sure you get all the way down to where x is equal, or x is by itself. And that is going to leave us, if you do 36 divided by 3.5, with 10.29. So Renzo working by himself, he would take about 10.3 hours. And this is rounded. So yeah, this came out to a long decimal, but rounding is fine in this case. So he took about 10.29 hours. She takes 8 hours, but if you combine them together, they can do it a lot faster in 4.5 hours. Okay, so there's another one like that. This one I already put the answer up for you. I didn't mean to do that, but it's fine. So this one says, again, pause it if you want to try and see. And now it's actually not bad that the answer is here, because you can try doing this by yourself and seeing if you get that answer to match. Now we're going to change this to minutes. This problem is in minutes. Okay, so again, if you want to pause it and try it, do so now. So Julian can mulch a garden in 20 minutes. So that means his rate is 1 garden every 20 minutes. Remy is, again, he's our mystery man, so he's 1/x. And then together they can do it in 11 minutes. Okay, so we're going to find our GCF here. And again, that's just going to be all of our denominators. So 20x and 11. So we're going to multiply everything here by 20 times x times 11. Okay. So just multiply everything there, and then each term is going to have something cancel. So on our first one, the 20 is going to be canceled. We're going to be left with 11x. Our second term, our x is going to be canceled. So we get 20 times 11, and I did that in my calculator, and I got 220. And then you're going to cancel the 11 in our last term. So that leaves us with 20x. Okay, so then again, get all your x's on the same side. So we're going to subtract this 11x. So we get 220 equals 9x. We divide by 9, and again, there was already a spoiler up here with the answer of 24.44. But that is your answer. So I believe we've reached the end here. and make sure that you do the homework that is online. Okay. Thank you guys.